Let's see why actually we called it random forest. Random forest. So first see the forest. What is meaning of forest? Forest. Forest, we have used this word of forest because of here we are taken the decision tree as the base models, because we have taken the group of decision trees, because we have taken the group of decision trees as base models. Because of these reasons we call it random forest. Now let's see why we call it as a random. Why we call this thing as random? Random we have calling because here we are randomly doing the sampling, means we are randomly doing the bootstrap sampling that we have this that thing we have already shown in the previous lecture. Okay, because we are doing here randomly the bootstrap sampling. Bootstrap. Okay, because of this we are calling this is a random forest. Now let's see how we will construct this random forest. And one thing, and we are taking here the best, it is the best bagging technique, bagging algorithm that most famous company, that is Google, Amazon, Microsoft, Facebook, these companies are mostly prefer its random forest because of its simplicity and its lower time complexity. Because of that, only because of that, let's see how these things actually. So the random forest actually means the random forest. In short, I am written here random forest, RF. Random forest means here we are taken group of decision trees, plus we are doing some sampling technique. Sampling, how we are using here bagging technique. Bagging. B for bootstrap sampling, and AGG means for aggregation. A means for aggregations. And how we will do the aggregations? The aggregations how we'll do for classifications, we have taken the majority vote, and for regressions we have taken the mean or median. Okay, that we have already seen in previous lecture. Now the one thing we have doing here, just we have, when we have seen the randomly bootstrap sampling, we have only taken here the column row sampling. Okay, just we will see this thing in, and now in the bagging we also have included one thing, the column sampling. Here we will do column sampling also. So column sampling means what? Column sampling means simple, it is the feature sampling. If you just see the in our data sets, the simple data sets in row we are using in row, in age row, in generally in age row we are using the features vector. Suppose x1, x2, x3, like that we are using, and in column we are using the features. F2, FD, if we have a d dimensional features, then we are using the d features in column. So here we are doing the column sampling, means we are sampling our data sets also in features wise. Features wise we are doing this job. So we are doing column sampling, means we are doing here features packing. Row wise bagging, plus as well as column wise bagging. Okay, let's see. And our dt, this group of dt is our base model. I am using this bracket here, curly bracket, always to denote for it is taken, it's a group of things. Okay, because of that I am taking this. Don't be confused what is this. because of these notations I am taking here this curly bracket. So base model, we have taken this as a base model for random forest. Now let's see the thing. So let's see, suppose let's see, it's our data set. It's our data set. Okay. So in this data set, we have, suppose let's take in this data set, we have n number of points in this data set. We have n number of points in this data set, and we have a d number of features. D number of features, f1, f2, like that, fd. We have d number of features. And let's call this data is, let's take dn, and we are using this data for a training purpose, for training our base model. Train. Now how we will doing this, how we will, first we have to doing this sampling, means bootstrap sampling. Bootstrap sampling, here we use row sampling as well as the column sampling. Okay, so let's take, now we are generating the data from here, the d dash. Suppose let's take, we are generating data d dash. So now the d dash, now for this d dash, our row, our number of data sets, suppose let's take m. How we will choose? We will choose this m data from the this n data. So first suppose let's take, here we have, suppose let's, I am using here different color, let's yellow. Suppose let's take, we have set of n points here, set of n points here. Now how we will choose? Here we will choose this point from here to here, generated, we have generated here such kind of m points from here to here. Suppose we call this set as a. Suppose let's take a. From here we generated a set b here. We generated a set b here. So b is here a subset of a. B is here a subset of a. Suppose let's take the b value is here. Suppose let's take here b is, I think it will be better if it's, instead of taking 1 2 3, if I am taking here a1, a2, an, n number of points we have. Or suppose let's take, we have m number generating b, so b will be here 1 2 b2 dot dot dot, dot up to bm. We have bm number of points. Okay, so but b is always subset of a. So don't be confused. ai maybe ai belongs to a and bi belongs to b, and these conditions also means b is also a subset of a, and this thing we are generating this subset by simple using here randomness, random algorithms, and the best random algorithms is the best algorithm, uniform distribution or normal distribution. Uniform distributions or normal distribution, that any kind of technique we have used to generate this random. Suppose let's take, so this is the other thing. So suppose let's take, we have for this subset of data we have d dash, it should be right, d dash, and in this d dash we have suppose m rows where m is less than n, and we have, suppose here we have d dashed features, okay, here, and the same techniques also here we will use to find the d dashed number from this number d, and d dash also here, d dash is also less than equals to t. Okay, by using this thing to generate the sampled data from the data, this is the sampled data. This is a sample data that is generating from our training data. Okay, now how will this thing generated, how these things actually generated? See, So here we have, I think how these things actually generated, you have already got this idea. Okay, suppose if we have f1, f2, f3, fd, so now here the samples value will be f1, f2, fd dash. Okay, I think you have got this idea. Okay, so here how doing, here we have doing row sampling for this one, for generating this one. Here we have doing here for generating their row sampling for m, and here we have doing the column sampling for generating the d dash. Okay, so means our the whole subset of data will be look like this. The whole subset of data suppose look like these portions, these small portions, or it would be these small portions, or it would be these small portions, or it would be these small portions, like that, like that we have generated, like that. Our data set subset means this is column sampling also, and also here we have generated row sampling. So after generating this, how we will do it? Just redraw this thing. So we have to generate a such kind of suppose k sample data, because we have interest to build. If we build the such kind of k random forest, k decision tree, then we have to generate it randomly such kind of sample data, d dash sample data. So let's draw this thing. Suppose we have d in data, and it's our training data. This is our training data, and here we have n number of points. Here we have n number of points and d number of features for this data. D number of features means f1, f2, fd, a d number of features we have. And from these data sets we have using, from these data sets here we are using row samples plus column samples to generate a data. Suppose let's take this data we have generated here, d dash data, d1. Suppose let's take, we call it d1, and here we have d dashed column, we have m rows, such kind of m rows. Okay, if we have d dash, suppose let's take here our column will be, column will be f1, f3, f9, like that, fd dash, d dash number. That is a subset of this set. Okay, so now by example using this data we have building our one base model. Suppose let's take using this data we are using one base model m1. Now we are doing the same job for this also. We are doing the same job, row sampling plus column samples also use here. Now we will build this d2 data set. Similarly here also it's another endpoint. This endpoints totally different. We have generating this endpoint randomly for one here. Again we have generating the endpoint from here. This m totally different. And also d dash, this d dash for d2 and d dash for d1 totally different. We have generating these things randomly. Okay, we have generated, so don't be confusion. These are terms the same, these are the total different set, different. So suppose let's take here we have f1, f2, f15 up to f number of d dash number. It will be number, I think, we don't confuse, this will be number of d dash point. So by sample using this, now by using sample this thing we are using our second base models. First, let's take, we have using this base to M2 model. So such kind of the same things also doing here for k thing, k, for just running, just continuing, we are doing the same thing, same job. Similarly, suppose let's take, we are doing the same dk set, similar kind of dk data sets. And now we have built, using this thing we have built our another model. Suppose let's take mk model we have built. Okay, mk models. Now what we have to do now? Simple, we have to now, after this step, we have to find its majority vote, or it's, suppose we have to aggregate this thing, we have to aggregate this thing, we have to build a final model, let's call m. How we will do this? By simple using the aggregation. We get the aggregations. And for classifications, we will do what? For classifications we will take the majority vote. For classifications we will take the majority vote. And for regressions we will take mean or median. We will take mean or median. That's the thing actually we have to build. Now the thing is for age AMI, age base model. These are the base models. So how these base models are look like? Now let's see how these things actually look like. First, let's take, we are picking any one of the k base models. Suppose let's take, I'm picking mi. So the mi for this random, actually this is our random forest model. These models is actually our a random forest model. This model is called the random forest model. Now the question is how it look like, the base model. Okay, the base model decision tree is a reason we have taken, because we know the decision tree, if we depth increased, if we increase the depth, that means our the models is more overfit, overfitting increased, means what? Means our variance increased, means if we small changes in our training data, so the models behave like model change like dramatically. But if we here, we this kind of situations here we don't face here. Because we have taken here bagging technique, that we will see. If bagging technique, we can easily reduce the variance term. So don't be confused, our model is variance or bias. So just taking age models just as a reasonable date. Don't be confused how much depth we have to choose for age models. So here for age based models we have to choose a reasonable date. That will be okay, because we have a small number of data points from the main training data points. So here if we consider all the training points in our model base model, so that will be okay. Don't be confused. So in decision tree, this AMI is a decision tree of a reasonable date. It's a reasonable date. Okay. So the base learner, these things are actually a base learner. These things, another language is called the base learner. So the base learners are low in bias. If we take the reasonable date, low in bias, and also it's the high in variance. This variance is high variance. So because we are taking here the bagging technique, because we have taken here the bagging technique, so these variances are now reduced. These variances now reduced variance. We have easily reduced variance in the random forest model. In the random forest models, these will be easily reduced. Okay. Sure. So what we will see here? We will see we have MIs such kind of base models. We have MIs such kind of base models, and these base models are generated from d-dashed sample data. This d-dashed data, suppose I am taking here d-dice data. This is the sampled data. This is generated from the sample data, and in the sample data we have d-dashed column, and we have m rows, where our m is less than number of main data points n, and also column is less than our number of main features. Column d means features, number of features. Here n means number of data points. Here d means number of features. We will see this thing. So there have one special name. So for to constructing the di from the da, the constructing di, the sampled, actually we have built the sampled from di. So to constructing these samples, they have a special name. Actually, how will these things look like? How will these things look like? Suppose let's take the big box, that big box that we have drawn here in yellow color. Suppose let's take the yellow color box is dn. Suppose let's take dn yellow color box. Just I am taking here the same color for different notations. Okay, so just now see the yellow color box. So this is the sample, our dn. This is our main parent data set, parent data, nd, parent, parent, parent data. Now from this data we will sample the data. We have taken the sample, some small chunk of data, sample data like that. This data, this data actually d-dash data, d-ice data, sample data. This data is actually called the sampled data, and from this data we will generate it our base models, MIs. We will generate it. This is a sample decision tree models. Now by averaging such kind of decision tree models, we will generate it the random forest, that we will see. Such kind of decision tree models, by example, we will generate the model that is our random forest model. Okay, so these portions of the data, these portions that is taken, this these portions means these blue portions of the data. These blue portions of the data is called the in-back sample data. In-back sample data. This blue portion data is called the in-back sample data, and the yellow portions data means in that data that is not used. Just see this, just see this pink color that is not used in d test. Rest of the data means this data that is not used, this data, this the whole data, this data means dn minus d dash di, dn minus di, this data is called the out back point data, out of back data, in a back, out of back, out of back points, or in short it is called OOP, out of back. Okay, I think this is the special name. Okay, this is the name that we call out back data, and we have taken this, we have using this out of data for cross validations. We have, that is actually for training the decision tree. We have using the sample data for training our decision tree. We have using the sample data. Now this outback data we have used, this outback data we have used for cross validation, for cross validations of the model. Okay, just that's that thing we will choose for cross validations part. So what we will see, we'll see that we have a base model AMI. On this, these models is built from a sampled data di that is generated from a whole data d, and the dn and a dn minus di, these things is called the, this thing is special name is called the OOB samples, out of back samples, out of back samples. And these things we have used for cross validations of our data set, for cross validations of cross validations of the decision tree model, of the decision tree base model, base model AMI, sorry, base model AMI. And also from this model we will find the OBB error, from this using, from this is cross with this sample data, this OBB sample data we will use simple use find the OBB error by simple using this model, and with the help of this data help model we will find the OBB error to retrain our model, this model better, to retrain this model. Okay, so actually if we just conclude this lecture, what we will see actually in this lecture, if you just conclude this thing in random forest, so what we will see, so in the random forest, just conclude this thing, in random forest is a branch of base learners, is a group of decision trees that is taken as a base learners, base models or base learners, same thing, base learners. Second thing is that we have taken here row sampling with replacement as well as column sampling also is replacement. Row sampling with replacement, also here we have taken the column sampling. Okay, And at the final step, what we are doing at the final step, we have doing at the final step we are doing the aggregate the thing, aggregating this thing, aging. Simple. I'm taking easy. For classifications, we have taken the majority vote. For regression, we have taken what we have taken here for regressions, mean or median. We have taken mean or median. That's things we have seen in to build a random forest. Okay. Okay, I think you have understand all the things, how to actually it is construct, and why this we call random forest. Okay, I think from this lecture the idea, the main key idea of the random forest is clear, all of you. Okay, so we'll see in next lecture.